Hi, welcome to today's lecture in our software engineering series. In this session, we will review the white box testing. Together, we will explore key topics including understanding flow graph testing, identifying independent program paths, techniques for conditioning testing, strategy for loop testing, and best practices for writing test case. Let's do it. Introduction. White box testing is sometimes called transparent or open box testing, as tester can see the internal workings of the software. It is different from black box testing, where the tester is unaware of the internal code and focuses only on the software behaviors and output. White box testing is focused on verifying that the code functions correctly at a detailed level. This means ensuring that the algorithm, control flows, and data structure work as intended within the system. In white box testing, the tester is concerned with the inside logic of the software, including verifying that conditional statements, loops, and functions call work correctly under various scenarios. Testers must be familiar with the internal structure of the application. This could involve understanding the program's architecture, functions, control flow, and data handling to create effective test cases. Key methods. White box testing, also known as structural or clear box testing, as I said, involve testing the internal working of the application. Unlike black box testing, which focuses on functionality from a user's perspective, white box testing ensures that the software's internal processes are correctly implemented and efficient. These testing techniques examine the program's flow, decision making, and structure, verifying that each part functions are expected. In today's session, we will explore key techniques like flow graph testing, independent program path testing, condition testing, and loop testing, and how to design effective test cases for each. Flow graph testing. Key components. Flow graph testing helps visualize the internal structure of the software, highlighting the logical flow between different parts of the code. By breaking the program down into the nodes and edges, the techniques allow tester to ensure that all paths through the code are covered. It helps the detecting edge cases or areas of code that have not been executed, reducing the chances of undiscovered defects. The techniques is especially useful for ensuring high code coverage, which means testing as many paths through the program as possible to catch potential issues early. Independent program path testing. Independent program path testing involves testing each unique execution path within the code to ensure that all parts of the programs are covered. This method is particularly crucial in systems with complex logic or decision points, where multiple paths could lead to different outcomes. A key element is identifying independent paths, which are paths that cover new conditions or transitions that have not been previously tested. For example, an if-else statement will have two independent paths, one for when the condition is true and one for when it is false. This type of testing is vital for verifying complex algorithms where different paths can produce different results. Condition testing. Condition testing ensures that all combination of logical conditions are thoroughly tested to verify correctness. It is critical for detecting bugs that arise from untested combination of conditions. For example, if a program contains a condition like Then tester must verify that the condition work as expected when x is greater than 5 and y is less than 10, as well as all other possible combination of x and y. This testing is essential for ensuring that logical branches are correctly followed, that error don't occur due to missed conditions. Loop testing. Loop testing is essential for ensuring that loops in the code behave as unexpected in all scenarios. Loops are especially prone to one-off by one error and infinite loops, which can significantly affect the program's stability. Different types of loops such as loops, nested loops, and unstructured loops need to be tested under varying conditions. For instance, loops should be tested with zero interaction to verify that the loop does not execute, and with the maximum number of iterations to ensure the program handles the boundary correctly. By rigorously testing loops, we can catch issues that may only arise in specific situation or extreme cases. Writing effective test cases. Writing effective test cases is a critical skill in the white box testing, as it ensures that all aspects of the code are verified systematically. Test case should be written with the program's functionality in mind, considering both typical use cases and edge cases or might expose flaws in the logic. It is important to clarify, define fail-pass criteria for each test case. This gives the tester a concrete understanding of what constitutes success and ensure repeatedly of the test. Takeaway: writing detailed test cases is essential for systematic and effective testing. The combination of white box testing methods ensure that every part of the code is tested thoroughly, from basic logical operations to complex decisions making and loops. By writing clear and comprehensive test cases, we create a roadmap for tester to follow and ensure consistent, repeatably results. These methods, when used together, contribute significantly to improving software quality, preventing defects, and increasingly reliability. Thank you.